Hi, I'm Greg Driscoll with PPP Transportation Safety Innovations. At PPP, we bring safe, smart, simple innovations to forward-thinking transportation organizations. In late 2019, we at PPP partnered with the Airfield Marking experts of Sightline to present a co-developed 4-part Airfield Marking Assessment Quick Reference Guide. This guide and the presentation cover the basics of specifications, inspection, evaluation, and management of airfield markings. The presentation was recorded and can be seen in its complete 2-hour-long form at pppcatalog.com/AFM. That's pppcatalog.com/AFM as in airfield markings. However, we're now offering this segmented series of videos that break out the primary components of that presentation into its 4 segments. Those segments are specification basics, inspection basics, evaluation basics, and management basics. Each segment ranges between 16 and 21 minutes long. So come along with us and let's drop in on the webinar presented by Mike Spidell of Sightline and myself. Our first segment is specification basics. Here we summarize what the FAA has to say about pavement marking material types and glass bead types and retroreflectivity. Let's drop in.
So here we'll summarize the primary FAA specifications relevant to the management of airfield markings, including marking material types, glass bead types, minimum retroreflectivity, and retroreflective deviation limits. Mike's going to start off here with us with the 6 most common marking materials. Mike?
Thanks, Greg, and good morning all. Thanks for taking some time out of your day to join us for this webinar. I'm going to start out with the 6 most common material types used on airfields. The one that you're probably most familiar with is the waterborne paints. There are also solvent-based paints. Those are single component products, and then there are also plural component products such as epoxies, methyl methacrylate, and the preformed thermoplastic is also a single component introduced into the airfield environment back in 2009. I predominantly see waterbornes, particularly specifically the type 2, faster drying, but we're starting to see a lot more of the waterborne type 3s. There are some very special characteristics that go along with the waterborne type 3. One of them being it's essentially a flexibility characteristic, allows you to build a little higher, get a little more paint down, provide a more thicker, more durable coating. I also like it in situations where you have asphalt pavements or P401, for example. It's a really good utility on those surfaces. Also works well on concrete.
Great. Yeah, I've kind of chime in on the same thing. Waterborne, just a couple notes. Waterborne type 1 generally doesn't retain beads well due to the resin that's commonly used, so be aware of that. Type 3 and some type 2 paints are designed, as Mike said, for this high build, and that high build is it will give you longer wear, and also you can get better adhesion of larger beads, which we'll be talking about beads in a few moments. But that longer wear, I think it's the Texas Department of Transportation. I think their actual pavement marking guide says the durability of a paint is directly related to the thickness of the coating, and that's somewhat true. So you have thicker paint, it's going to last longer. Next is, well, that'd be a thicker line, not necessarily a thicker paint. Thermoplastic is the most common material that's used on our roadways, and it's very durable. We just did a 6,000-mile assessment, and I think about, probably 70% was thermoplastic. So there's a lot used, but it has limited use on airfields, mainly due to its heat limitations and its weaker adhesion to concrete surfaces. And one last thing is just note that not all paints are the same. Even if you could have 2 type 3s or 2 type 2s or 2 type 1s next to each other, and they can be very different in their color ability to retain the color, their adhesion, their cohesion, which is bonding together without fracturing, their bead retention, application thickness limitations. Some paints you can build high, some paints you can't. Weather resistance also can vary. So just again, understand that not all paints are the same for sure. Okay, the next topic is beads. So the most common bead types, and you see here we have type 1 and type 3, which are the most common beads at this time being used in the airfield. So a couple notes I have on this is type 1 beads are most often are made of a cullet or crushed glass, recycled glass, vehicle windshields, that type of thing, and they crush all that, and then they make these beads out of it. And that's compared to a type 3, which is from a cleaner, clearer virgin glass. So that's one of the advantages. Your type 3s are going to be much cleaner and clearer usually than your type 1s. Also, type 1s have lower retroreflectivity levels than that of type 3 and don't perform very well when they're wet. So you have superior wet visibility with a type 3 bead. And then also, I want to be careful because we're using a general term here saying type 3, but the actual spec is TTB1325D type 3 high index reflective glass beads. So these are high index beads, which is a little different. There are some type 3 drop-in beads out there that are not high index beads. And that's what's giving you that ability to see through or get that retroreflectivity under wet conditions and so forth. And then lastly is there are other beads, and I've seen some type 2s used sometimes, and even the type 4, which normally you can type 1, type 2, type 3, type 4, they usually get larger. That's where your type comes in. So type 4 is is like the largest bead that we're using in markings, and usually, and it can be used only when you're using a type 3 high build paint because you need that thickness of that paint in order to embed that bead deep enough into the paint to make sure it stays. And these are great for wet conditions as well. So, Mike, I'll hand it over to you.
Thanks, Greg. Yeah, really good information. On the airfields, we do not have a type 2 bead. We used to, but it's no longer approved for use on airfields. We have type 1, type 3, and type 4. But as the slide says, the most common bead types that I see used on the airfields are either 1s or 3s. And to be perfectly honest, I don't see any reason to go really outside of that unless you're using a thicker, more durable material, something like a preformed thermoplastic, where you have the depth, the thickness of material to hold a physically larger bead and properly embed that. With the typical applications that I see, type 1 and type 3, again, are the most commonly used. One special note about type 3 paint, or excuse me, type 3 beads, is you are not allowed, prohibited by the FAA, to use or apply type 3 glass in red and pink paints. And there's a lot of backstory to that. I'm not going to get into it now, but just understand these are the most commonly used, and these are the ones that I endorse with my clients. I think that the type 3, you'll see here in just a few minutes, it performs better as far as a reflectivity, from a reflectivity standpoint, nighttime visibility standpoint. It performs better initially and over time, but both certainly can be applied very well and perform very well.
Okay, thanks. Yeah, and I'm glad you clarified that that type 2s are no longer used in the airfield. That's good to know. Another thing, just if you ever have the two beads and you think, well, just one's, and quite frankly, one's about 10 times the price as the other. So it is the high index beads are expensive, but if you ever put them in your hand, in the palm of your hand, boy, you can see the difference, let alone when you put them on a marking. There's a substantial difference in retroreflectivity and so forth. So we, again, like Mike, we support the idea of the use of a high index type 3 bead. All right. So now we're going to move on over to minimum retroreflectivity, and I'll hand that over to Mike and let him get us started.
So this is a chart. It's a very pretty chart compared to the one that has been recently added to the FAA's new construction advisory circular, and that is the AC 150 5370-10. And the newest iteration of that is H, or hotel. It was published December 21st, 2018, so very recently, and it included, in addition to some initial target values for type 1, type 3, and type 4 glass, brand new installations for each one of those materials. It also included, the last line was essentially a minimum standard or a threshold at which the FAA believed that an airport should consider remarking. So here are your levels right here for on white markings. Your retro levels should be 100 millicandelas or greater, 75 millicandelas on yellow, and 10 on red. And that is irrespective of material type. So I don't care really whether it's waterborne paint, preformed thermoplastic, type 1 beads, type 3 beads, it doesn't matter. They're saying these are the minimum standards: 100 on white, 75 on yellow, 10 on red. And this is it's a big deal. It's probably the biggest thing that's happened since.
We lost your audio, and we got it to. This is a big deal. It's and that's where I'd pick up at as soon as we get your audio back.
Okay, can you hear me?
Yep, got you now. So
Okay.
just go ahead and start with, this is a big deal.
And this is a really big deal. It's probably the largest standard change I've seen in 15 years, my time in the aviation industry. It is essentially defining how airports must objectively measure the performance of their airfield markings, the ones that are existing, not necessarily during new construction, but how they're performing year round. And this is something that I think that Greg and I, we align on. We think this is a really good idea. This is a good thing for the industry and for safety in general.
Yes, absolutely. We've seen the Federal Highway Administration has been working for years on creating a minimum. Hopefully, we're going to see that by the end of 2019. Understand that these numbers, this 100 and so forth, these 175 and 10, they're not very high thresholds, to be honest with you. And we go into more detail of that in some other webinars we do as to what a millicandela is and what that means and how we measure it and that kind of stuff. But what's important to know is that even though they're not very high, they frankly they're actually exceeding the requirements, some of the requirements of the Federal Highway. So I really applaud FAA for moving forward with this. And like you, I greatly support the idea of having minimum levels for safety reasons. Also note that we experience much higher numbers than this 175 and 10 on our better airfields that are using these type 3 high index beads. In fact, we did one assessment on our end. Just we don't do assessments like Mike's team does, but we go out and just for promotional reasons, or we're trying to learn more about the industry or something. We did one, and I think the average on the entire airfield was like 690 millicandela, 640 millicandela, something like that. And that was white and yellow combined. Now that was high index beads. So you will get a difference there, and you've heard us talk a lot about that already. Also, note that yellow is lower level, and it's usually that because yellow, or the darker the color, the more light it absorbs, and it struggles to return the numbers as high as the lighter colors, and that's why you see the requirements drop as you get to a darker color. And probably one of my things, and we'll talk more about it in a little bit, is just to be cautious that your yellow doesn't reflect white. You can have a yellow line that at night can appear to be white, and we'll cover that here in a few moments. So that's all I have. Let's move on to the next one. The next section is on retroreflective deviation. So basically on retroreflective deviation, there's you take 6 readings within a 6 square foot area, and you go a minimum of 3 directions. You see here is just kind of a drawing of using a handheld retroreflectometer. And the maximum variance between your readings can be up to 30%. Now, this spec is unique to the airfield, primarily because the roadway system doesn't normally have such large markings that could vary in retroreflectivity substantially across a marking. Most of this, and we'll talk more about the application and so forth, most of this is caused because you have multiple guns applying the material and so forth and overlapping and so forth. But this is very unique, and 30% is somewhat substantial, but sometimes you could be surprised at how easy it is to meet that 30% threshold. So, Mike, your thoughts on this?
Thanks, Greg. Yeah, this is something that the FAA specified in that same advisory circular I mentioned earlier. They're essentially looking for uniform appearance at night. That's really what this 30% max variance is all about. And I think it's a very smart thing for them to specify because, frankly, with any piece of equipment that is measuring reflectivity, you can get really good averages, but it doesn't tell you how uniform it is or how pilots or even drivers of ground vehicles are perceiving it. So this addition, the 30% max variance, is, I think, something very important. What we see during our airfield marking assessments is that very often material distribution is inadequate, and it relates directly to how uniform that marking is. So the fact that we're not only looking for performance, but uniformity in performance is key.
Thank you for joining us for our segmented video series on the Airfield Marking Assessment Quick Guide. And a special thank you to the Sightline team, who without their experience and expertise, we could not have produced such an informative presentation. Get more information on this series, case studies, tools, equipment, and services for airfield marking assessments at pppcatalog.com/AFM. Again, that's pppcatalog.com/AFM, as in airfield markings. Thank you. Have a great day.